Hey everybody, Adam Savage in my cave, and I am in a part of the cave we don't often film. This isn't an angle we are frequently covering. This used to be where the welding table was. For a long time I had a bunch of costumes set up here. We tried to set up a big 3D printer here, and then that went away, and then an even bigger 3D printer came in, and that is what is here. This is the newest 3D printer that we get to play with here at Tested, and this is from Formlabs. It all arrived a little while ago, and a technician is about to come and open all these boxes. What this is SLS, a sintered nylon 3D printing system. And I have been experimenting with all sorts of different printing systems, filament printing systems, resin printing systems. This is from the Form 4L, which we love, and I really dig the clear resin. Sintered nylon is maybe my favorite 3D printing process to work with. We made the Ambin rifle and also a bunch of my Star-Lord costume parts out of that. And I've always had to go to friends who had large shops that had SLS systems to do my printing before. This brings that capacity here into Tested. I've been begging Form for an SLS system for years. I am so excited to fire this thing up and try a printout on it. Sintered nylon is, look, there's not a lot of discussion in the world right now about archival printing. Archival is the museum term of art specifically for how long something will last. And so in museums, they try to use archival materials, i.e. Materials that don't off-gas acids or things that might wear or deteriorate the objects that they're preserving. And within 3D printing, we don't know how archival the materials of 3D printing are. PLA could all sort of start to melt 20 years from now. We don't know. But nylon is a pretty stable material, and while I don't love working with it on the machine tools, as a 3D printing matrix, it's my favorite. It's super durable. It has a high fidelity for surface detail. And did I mention it was super durable? That's maybe one of my favorite features, is just how impact resistant and durable these things are. But we're gonna start setting it up, and then we're gonna make our first print today. That's the goal. That is super awesome. I need longer gloves in my sandblasting cabinet. All right. Okay, look at that. So that's the platform.
Yep.
Oh, amazing.
That's the part that lowers and raises. So when you put it over here into the fuse, this is the part that will be facing out. So if you turn it around
and put it in this.
Slides on the rails.
Ooh.
Yep. And then that top part comes back down to latch into place. Plug
And
those in
that
hole.
comes in. That is a lot of connectors. So this is where the build happens.
Yep.
There we go.
It's powered up.
Just a few minutes, we'll have some cake. Okay. And Phil.
Nope, 100%. Yep.
Part of owning a new 3D printer is the first print, and that is what has happened overnight while we were gone. This isn't an announcement about the first print. This is actually camera footage of the first print in there, and Jason's going to walk me through pulling it out and cleaning it up. Good morning, sir.
Good morning.
I'm very excited. Does it seem like everything went smoothly?
Yep. Looks like everything's all ready to be pulled out and depowdered.
Okay, do I do the
Right there,
slide?
yep, slide.
Slide to open. Here we go. Oh! All right. Okay, so now...
You always want to check the temperature.
Oh, right, yes.
After, we know it's pretty cool,
We assume
but
that it's
right here,
right.
bed temperature.
Great, okay.
Yep. So that's safety. We can pull out the plug there.
Gotcha.
Yep.
Plug is pulled out and plug is stowed.
Now the one on top right here.
This guy
Yep.
here.
And then pull it straight out, both hands on the sides. Open this one for you.
Ooh. And in a few minutes, we'll have ice cream.
So the next part is, if you want to use the glove box here, you can move these out of the way, get them all ready for you.
Mm-hmm. Okay, and then I want to pull this cover off.
Yep, cover comes off.
All right.
That's to generally keep any powder from falling down into the build chamber area.
Gotcha. That makes total sense. All right, so let's see here. There we go. Does this store somewhere?
You just put it up against the side here if you'd like. Perfect. And then the buttons to control the build chamber Z-axis are right here. So you can either just tap the up or hold it down to control specifically.
All right.
how
So
far
I
up
don't
to
want to bring it all the way up right away. Do I?
You can.
Right.
Try it just halfway to start.
And I'll tap it again to stop it?
Yep.
About there?
Mm-hmm.
All right. And now, and then what?
This is the fun part. This is
This-
extracting. So
this
you're going
is?
to push the cake over the sieve.
Over
So
the
just,
sieve here.
Yep, grab it with those gloved hands.
All right. Oh my goodness. Whoa.
You can take the title off there. That's an optional feature you can turn off or on in
What,
freeform.
the title?
Yeah.
Oh, wow.
So it can mark your prints.
Oh,
what's
that's
in there.
actually not the, oh, wow. That's just the what happened.
Mm-hmm.
Oh my goodness. Okay. So now I'm extracting.
Mm-hmm.
I'm just looking for the pieces.
there's one.
There we go.
Yep.
All right. So, okay, I get you. There's a lot of, the powder is very tight on it.
So the top ones are going to be the ones that had the highest temperature. So
Mm-hmm.
the surface armor is going to be the most solid.
Right.
The ones at the bottom, the surface armor is almost going to fall right off.
Oh, look at that. And now the print, we're starting to see the print in there. All the little cones.
Mm-hmm. Feels like excavating.
It really does. It's very satisfying. You know, I've been saying for a while that I think 3D printing is the hobby for people who like picking scabs.
Yeah,
Right?
absolutely.
On to the next one. And
Any
this
of
is-
these big pieces that you have
Yeah.
here, you can kind of just crush them into
Oh,
the...
really?
Yeah.
Oh, that's fun. Yeah, I will do that.
And once you reach a certain amount, you can press the sift button and it'll actually start the vibration.
Oh, right. It goes through this. Oh, wow. So that's just the label. Amazing. All right. There's very, very little powder left in there.
Mm-hmm.
Could you turn on my vacuum? Now I see why you have all the rounded corners in here.
Yep.
Very smart. Oh, look at that. It's a lot. Gonna put that there. Sift. Woo! Oh, that was neat.
Dude.
All right, Jason, these are the 5 printouts, and these were stacked on top of each other, yes?
Yes.
Okay, and these are, this is sort of how we get to understand the extreme subtle end of this printer's abilities and to calibrate it to do the best possible job, right?
Correct. This is the fine tuning of the temperature, and it's only going to be a change of at most 2 degrees higher than the baseline or 2 degrees lower than the baseline.
So what you guys found was at the factory, you could get these things set up reliably enough to get within a few percentage points of excellence, but this last step is what takes it that last step, yeah?
Yes.
Okay.
And what we're working here with is Nylon 12, which is one of the more forgiving powders.
Okay.
It's good to tune it just to get the max out of your prints.
When you say forgiving, I just want to help the audience understand, you mean sort of able to do its job within perhaps a wider range of variables than other materials.
Yeah.
So it will hide your crimes for you, perhaps.
Yes, exactly. It's my favorite powder to work with.
Okay.
So one I recommend everybody try.
I love me nothing more than a bread and butter material to play with.
Absolutely.
And then these are printed stacked on top of each other, and the machine adjusts the temperature to witness the behavior.
With the temperature tuning, it's the only time in which it's going to start at one temperature at the bottom and be at a different temperature when it gets to the top. It's slowly raising the temperature as it's printing. So over here, you have the lowest temperature. This is -2 degrees at the very bottom where it starts the print. And then as it goes up, it starts raising the temperature until it gets to the very last one, which is +2 degrees.
And it only ever does that temperature change when it's doing this calibration?
Yes, when you're actually printing, it's going to maintain the temperature throughout the whole print, the one we set it to.
Okay, so this is a total difference of 3.5 degrees, it looks like. -2 to 1.5, 1.4. What do we learn from looking at these? What does your expert eye see?
So you have a couple things to look at. We're going to look at the surface of these cones.
Okay.
And what we're looking for is essentially what we call birch barking, a layered effect that kind of shifts around as it goes up. And you can see it on some of the cones, but not the others. On the same one, the kind of a hot spot in the bed. But generally, if you see it, it gets worse as the temperature goes up. And that's where you want to dial in your temperature offset, is where you, right before you start seeing that.
Okay, so I don't see any, you sent me an email, showed me a picture of the birch barking, but it looks to me like this is an excellent example for you guys of a very, like the quality from the beginning to the end is pretty consistent.
Yeah, you don't
I'm having
see
trouble
hardly
noticing
any birch barking.
I'm having trouble noticing a difference in the visual or feel of these cones across the whole range. But what else do you look for to decide upon where the temperature should land?
The other thing we inspect when we do this temperature tuning is actually flipping them over to the other side. And this grid pattern has area in between that you can start to see what we call dimpling.
Oh, okay, that's the dip in between the squares?
Yep.
Okay.
So you only see it on a few of them.
Oh, okay. So almost no dimpling
all
here.
the way down there at the end. Yep.
Slightly less. I mean, slightly more dimpling, but very subtle. And then over here, significant dimpling. Like that is a very big change from.
That's -2 down there. So you will see that just slightly here and then none there. So what you want to do is probably set it at -1.5.
Okay.
And then see how that, when you're running your regular prints, see how that looks. And then if you see even a little bit of dimpling in any of your other prints, bring it back down to the -2.
Okay. So does this mean that we now have done enough to send our first, I don't mean to say real print, but print from this shop?
Yes.
Yes!
Absolutely. You've reached that point where you can start your own shop print.
That's very exciting. Let's shop print.
Adam, I'm so excited. Okay, so Jason
walked us through everything.
Absolutely, and but we haven't done our prints yet.
Yeah.
Like so much of this is going to be about, like with other printers we've had, just building those reps.
And how this integrates into the shop's process. So the first print is done. I love that it's called first print. And now we've got to follow Jason's protocol through cleaning and processing.
Yes, yeah. We're not touching on the full ins and outs of the software, but you gave me some models and I processed them. We're not revealing exactly what they are right now, but fingers crossed they'll turn out. I'm so curious.
I know. I'm really, really excited about this.
Shall we slide to open?
Okay. All right.
There we go.
Dude.
I love that.
I know, it's kind of great that it just prints a little card with the title.
Yeah, exactly. And that the visualization there is a direct camera feed.
Right.
Like you're seeing that nylon get sintered, hardened in real time.
Yeah.
Because it's the build plate or whatever you call it, the chamber that's moving down.
It's really neat watching the laser go across and watching what looks like the sintered nylon boiling. It looks a little like there's boiling going on when it's going. So we can pull this, right? Okay, do that, and then bring this over, put that there.
Our build chamber is removed.
Removing the build chamber, dude.
Oh, so that's extra nylon powder.
Right, this is what we want to recover.
Oh yes, that's right. And we're gonna slide it over
Go.
and get it into the
I
sift.
probably don't need to be quite this careful, but it feels like it's very delicate. All right, that's in, that's locked. This is connected. Okay.
This is the part of the process I'm the most curious about. I watched you and Jason do a bit of it, but because no supports are needed,
Right.
like it's the archaeology of it, like how much cleaning, how much of it do you need to get ready before putting it in the blast?
Yeah, so just to reiterate for those watching, this is a system that prints in powder, and so when it's done, the parts are all suspended in powder. The most surprising thing to me about this process was that the print takes a normal amount of time that you'd expect, 5 to 10 hours, depending on its complexity or more, but that there is like an almost the same or greater amount of cooling down time. The powder sitting there holds the heat on the part, and if you pull them out too early, they can warp.
Yeah.
So the cool down time was a very surprising aspect of this, and we're removing all of this heat holding powder from around the parts.
And that's a powder, again, that we want to reclaim and reuse and put back in the hopper.
That's the other part, is that almost all the powder we're removing goes back into the system and can be used for printing again.
Yeah, with a mix.
Right, right.
Okay, so we have it on. The chamber is ready. Shall we unpack?
Yeah, let's
So there it goes.
Now what we found talking to Jason is that we don't necessarily need full glove box. We've got a really nice pressure moving in here. So it's up, right?
Yep, we're in the unpacking.
So now this is just taking the chamber that went down, 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 down for each layer and bringing it back up, 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 up. And we don't have to expose the whole amount of it. We can just start bringing it there.
Do you want to put gloves on?
Yes, that's right. Let's do gloves. Every time I think gloves have gotten as thin as they can possibly get, they get thinner. First up. Yeah, you see the airflow? It's great. It's like a fume hood. Well, it's not like a fume hood. It's an actual fume hood. All right, so there's the first bit. I'm going to reach down into here. Oh, it's still, I can still feel some warmth. Okay, there's one piece. There's another. There's another. Oh, this is very, very fun.
I'm applying just the lightest of like finger pressure and parts are falling off, but I can tell it's still pretty densely packed.
Right around the printing, it's quite dense. But still, you can affect it mostly with just your fingers. Yeah, you're right. Okay, I'm just gonna get all the big chunks over here. There's another one. Oh, more parts. I'm really blown away by the density of parts in here, dude.
I think that's one of the things that they advise, right? Normally when we print FDM or SLA, we're not concerned with how optimized that build plate is.
Right.
And here, the denser the objects are packed, the more efficient use of the nylon.
Right, you're rewarded for high density.
Yeah.
And density is something you can get super dense because these are all just suspended in powder. No support. It's hard to overestimate how exciting the idea of no supports on the prints are in terms of like how we lay them out, what we actually do with them.
For me, terrifying. Like no cupping to worry about.
Right. All right, almost there for all the small chunks. Dude, the density you got out of this build volume is incredible. Okay, I think I have all the parts but one. and it's this half scale. I think that's gonna be
Oh,
me when
that's
we're
a
done,
nose.
right? Okay, here we go.
Oh my goodness.
Actually, let's try this one.
The Sandman.
It is. It's reverse Sandman. Oh, look at that great hair. So now, as we're peeling powder off of this, we're not trying to get 100% of all the powder off of it.
I'm curious about that. We know there's a blast
Right.
process. Like, how much of, I want to get as much in here.
Yeah.
But like, how much work do we want to put into the scrubbing and the poking and
Right,
the loosening of all these parts?
Nice work on the
Yeah.
open holes. So that's part of the slicing software, right?
Yeah. I hollowed this. This was a solid piece. I didn't want to make it a solid piece of nylon. So
No, God, no.
hollowed it out and it's used their drill feature in preform to punch out the back.
That's great because that made removing the powder of that really trivial. What is this thickness, a millimeter or so?
2 millimeters.
Okay,
But you can adjust that.
you can go even thinner.
Yeah.
Oh, nice.
This is funny. The model
Oh,
punched out the
yes!
holes.
In situ. Oh, that's great.
It's not the right way technically. If I had better CAD skills, it would be a Boolean operation.
All right, I feel like that one's pretty good. Okay, first off, there's a sound I've been loving. That. There's a way in which these things sound fundamentally different than any 3D print I've ever been dealing with.
They sound durable.
What?
Right? They
Yeah, sound durable. They
Yeah.
sound like hard plastic.
Yeah. Even though that's 2 millimeters thick,
Yeah.
I mean that's strong.
It's really,
Right.
really strong. And that was not bad. That was about 10, 15 minutes.
That's
of
exactly
some
it.
post-processing.
And I think we're trying to figure out as we go through our reps how much work we want to put in
Right,
to
by
the
work, how
cleaning.
much powder do we want to recover as
That's
we're
right.
scrubbing?
and how much we need before, or how much the blast here
can
actually
take care
remove
of.
and take care of for us. So here's a good example. We have these two, I guess they're 1/7 scale
Okay.
heads at them. And one we did pretty thorough cleaning, including the inner
Yep.
hollow cavity. And this one,
Very
just-
little.
Yeah.
And it's not like we're losing a ton of powder by letting
No,
the
no.
bead blaster do that.
Yeah. It's
Okay.
just like how much extra scrubbing in there.
Let's see how they come out.
Yeah. The bead blaster right here, glass media, ready to throw it all in?
Yep, I think I am. So this is all of our clean parts, and we can just start. Here we go. That sound.
Fragile? No.
Fragile.
Oh my gosh. I feel so wrong.
I know. It sounds great. Okay, so that over, and that down, and start.
We have a custom preset. We'll do 5 minutes of
And then
a
we just stop.
blast, and we're gonna, take a look.
All right. Wow.
I looked at the drying instructions for these, and it was low tumble, high PSI.
All right, is it time to reveal?
I think it is.
All right. That sound, dude. It's actually, I thought I was scrubbing really hard, but it's really clear how necessary the bead blasting is for a final finish step.
These parts look so good.
They do look good. They feel, wow, they feel amazing.
Oh, God.
Huh. It's the solid. Oh, wait, we got a head. Oh, okay.
Oh, okay.
So this is actually really interesting. I think you can see which one we scrubbed harder. So for tiny, tiny details, I think it's clear it behooves one to do some extra scrubbing before bead blasting.
Yeah. Or we could run it longer in the bead blaster.
Or we run it longer, yeah, one of those two.
I think that's it.
All right, shall we put this guy back in?
Let's do it.
Okay. That sound.
Let's look at the prints.
Okay, all right. Big head.
Okay, so this is a half scale of your carbonate head, of course. Hollowed out using the preform software, 2 millimeter thick walls. I used Formlabs' own drilling software.
To create holes for evacuation.
Yes, and you can tell my mind is so much in the SLA mindset. That
Or you made drain holes.
I made drain holes for like washing with IPA, but you know, obviously
not necessary
the
for
powder,
this process.
yes, operates a little bit differently. Wow, look at the inside.
No, I know. It's really, really crisp and clean. It's kind of amazing.
Because there was probably a lot of powder.
There was
packed.
and I
this
really
interior.
scrubbed it, but there was also still a bunch of powder, and it is really all gone.
Yeah. The detail, the texture is unique to the powder.
Yeah, there is actually still, yes, it augments, I think it does a really great job augmenting a skin texture, right? Like there is it's not the highest resolution, but it's so crisply at its resolution that it's sort of, it's a little bit of, I don't know, it's that, what do you call it? That slightly pebble texture, which probably disappears with one coat of primer.
It's almost like noise. Well, then you don't have to put sandpaper on it to get primer to stick. Maybe.
Right, yeah, plausibly.
Yeah. I auto-oriented this. So one of the things, you know, when we do FDM or SLA prints, orientation of a print is so important.
In terms of where the lines show
For the
up.
layer lines, for supports, but I just trusted the system because density was the most important thing.
Yeah.
Right, and yeah, I can see where the layer lines are. This is 110 micron layer height and did print like that, flat basically. But I think the noisy texture of the powder almost supersedes the layer lines. It
does. And let's just be clear, 110 microns is it's 4 thousandths of, and give or take, 4 thousandths of an inch. It's about a thick sheet of copy paper. So that's it's actually a dimensional, but it's really hard to see it. God, that's gorgeous.
Very surreal. Okay, let's look at the other pieces.
We've got some, here we go, some body parts.
All right, I'm just gonna start laying them out.
Yep, oh, there's your head, some accessories, backpack, torso. All right, let's see here. And then we've got one more upper arm. And, oh, there's my head. Okay, so will these parts even click together at all, is my question.
And again, here's the questions I had, because these are pretty big cavities where the ball joints are supposed to fit. I wasn't going in and scrubbing in the entire interior surface of these cavities. Right. And if I just put my finger in there, it's a little bit of powder on my finger, but it's not a lot at all. Like that is pretty thorough. In terms of
I can
blasting
still
it.
see a little. Wow, I'm actually curious if these will even click together at all.
There's no flex?
No, there's no flex at all. These are built. Okay. Wait a minute. Let's try it. Let's try it.
Let's do
this
one
is
of
a
more of a
thigh,
press fit.
and this is a thigh, right? Okay, so those are okay. So that's a left thigh. No, it's never going. We build action figures that cannot be assembled.
We have tools to maybe make this happen.
Hold on. Okay, I'm grabbing something. Yes, I got a rubber mallet.
Yeah, yes.
Rubber mallet.
Clamps and a mallet.
Okay, here we go. Let's try. So this is a left thigh, and that is, yeah, that's the butt. This is the front. Okay. So what I want is...
Do you want it on a vise, or you want to hold it?
Well, I'm trying to see here. Here, if you'll hold the back of that, there we go. And then I'm not in danger of, all right. All right, you ready here? Here we go. Oh,
that was just parts, yeah, that's...
Okay.
Oh!
There we go. So we've shown it conveniently split into 3 large chunks, which I honestly, even if you could get it in, I think this is designed for an older process of 3D printing.
Or something with more flex.
Yeah.
Yeah, the rigidity of these parts. I mean, they're just not made to bend.
Oh.
Wow.
I was all like, we're gonna assemble some action figures. And the answer is no, you're not. Okay, let's see if even these.
Yes. Let's see, arms and hands.
Yep. There we go. No, there's no way it's fitting.
Oh, right, because it tapers.
Yeah.
It tapers.
It has to, yeah, no way will that ever fit.
One last test.
Oh,
pegs. The simplest joint.
Pegs.
Okay.
Pegs could work.
Can we do? Let's see if the peg with the mallet. I mean, it's interesting.
Oh, it's a press fit.
It's a press fit. Right.
Oh wow, they've made it a. Oh wow.
It's an accessory.
All right.
So let's see if that works.
Jesus wept. We've overshot our mark.
Yeah.
We've ended up with 1 kilogram's worth of hard plastic parts that we can do nothing with. Nothing I have ever produced through a rapid manufacturing system in this shop has felt quite this amazing.
Yeah.
And the sounds of these things, they almost ring.
Knowing that you have rigidity, durability, even at thin thicknesses, what goes to your head is the types of projects and props that you might want to make using this process, because you can tap them, right? You can take it to the machining tools.
Yeah. Right off the bat, the first thing that was occurring to me was clockwork.
Gearing.
Specifically, gearing and slip fit stuff is very, very difficult with other printing processes because of the post-processing and because of very fine fitment. I feel like this process is custom made for that sort of mechanical printing.
Yeah. I mean, we got just a little taste of what that post-processing workflow, the range of what you can do, but we barely scratched the surface in terms of what the input, the types of files, the types of scale that we can put into the machine, and I can't wait to get started.
No, really, and truly, just hearing these parts bang into each other gets me so excited. I've been wanting this process in the cave for years. It's delightful to finally have it here.
And for me, it's it's another tool in our tool set. It's going to live alongside SLA printing, FDM printing, machining, and oh man, it's going to be a fun year.
There's going to be some fun spacesuit parts to make out of this stuff.
Just not toys.
Just not these spacesuits, yes. Thank you guys so much for watching that video. I would be remiss if I didn't tell you we have some excellent merch. We have a 5-pack of demerit badges for sale right now at tested/store.com. We've got the I hung it off of level demerit badge, the I built the chair backwards demerit badge, the I hit my thumb with a hammer demerit badge. We've got the stapler in my finger demerit badge, and my favorite, I stuck the duct tape to itself demerit badge. Get yours now, tested/store.store, tested-store. Tested. It's right here. There. Just click there.